This video is for 8-1 Factors and GCF, and this is a reminder of what your page should look like for your notes. How is prime factorization and GCF related? Throughout this video, I will discuss how prime factorization is used to find the GCF for monomials and for constants. Here is the factorization of 12. If you notice, we have the different forms or ways to rewrite the number 12 in terms of factors. That means numbers being multiplied to each other. So here we have 1 times 12, and I told you in class today that this was the easiest one, but the one most forgotten about. 2 times 6 gives us 12, 3 times 4, 1 times 4 times 3 also gives us 12, and so does 2 times 2 times 3. But notice how I have this one circled. This special group of numbers is called the prime factorization. That term there. This is the prime factorization of the number 12. It is the number, all three numbers can be multiplied to equal 12, and they consist of prime numbers. So today in class, you used a factor tree to come up with your prime factorization, and we'll also use prime factorization to help us come up with the GCF. So let's write the prime factorization of 98. And the method we're going to use for this is the factor tree. So you have to think of two numbers to begin with that go into the number 98. And 98 is a pretty big number, and there's a lot that goes into 98. But I know for sure that the number 2 will go in there because 98 is even and is divisible by 2. So I'm going to go ahead and write 98 divided by 2 to find out what times 2 will give us 98. So 2 goes into 9 4 times, and we get 8. Minus, you bring 1, bring down the 8. And 2 times 9 will give us the 18. Subtract, that would give us a 0. So 2 times 49 will give us 98. So here we have 2, 49. I can't not reduce 2 further because it is a prime number, but I can reduce 49 because it's a composite, and we get 7, 7. And now notice, and some people say this is at the end of our tree. Notice at the end of the apples at the end of our tree have all prime numbers. So our prime factorization for the number 98 is 2 times 7 times 7, or we can write this as 2 times 7 squared. 2 times 7 squared, or 2 times 7 times 7, will give us the number 98. Okay, now we talked about prime factorization, and I showed you how to come up with the prime factorization for a number using a factor tree. Let's now talk about GCF. Factors that are shared by 2 or more whole numbers are called common factors. So we have the factors of 12, and they list up all the factors of 12. 1 times 12, 2 times 6, and then 3 times 4. Then we list all the factors of 32. Okay, here are the factors of 32. And notice all the numbers in red are the common factors. And the common factors for 12 and 32 are 1, 2, and 4. However, the greatest of these common factors is called the greatest common factor, or for short, we call it GCF. So notice our common factors are 1, 2, and 4, and the greatest number here is 4. So the greatest common factor is 4 for the numbers 12 and 32. This is going to help us factor using GCF. And here, with this example, I'm demonstrating to you how prime factorization is related to GCF. So we're going to find the GCF of the pair of numbers 26 and 32, and we're going to use prime factorization to do that. So as you can see here, we have number 26, and it's broken down into its prime factorization of 2 and 13. And we have the number 52, and we have it broken down in prime factorization of 2 times 2 times 13. And now we need to identify their common factors. So here they have a 13 in common, which is why I write 13 here. And they also have a 2 in common, which is why we have a 2 here. And 2 times 13 is going to give us 26. So the GCF of 26 and 56 is 26. So I have a question for you. Did you know that your GCF of 2 numbers could also be one of the numbers? Well, if you didn't know that before, now you know that even though 26 and 52, the only thing they have in common is the number 26, and that is the GCF for the 2 numbers.